Greetings to you. Welcome to Physics with Ben. In today's video, we want to look at WASSCE 2016 Physics 3 Practicals. Question number 3, Electricity. Please kindly subscribe to Physics with Ben. As you do that, the Lord will bless you. So let's begin. In today's experiment, we want to verify Ohm's Law. Ohm's Law states that provided the temperature and other physical conditions are kept constant, the current flowing through a conducting material, e.g. a wire, is directly proportional to the potential difference across its terminals. That is the law, and mathematically we have V is equals to IR. So V is equals to IR is the equation controlling the whole of this experiment. Meaning when R is constant in this experiment, R is fixed, and this is 2 ohm. V and I are the variable parameters in this experiment. As V increases, I will increase. So in this experiment, I predict that we are going to have an increase trend. So let's quickly look at the practical instruction. So that is the diagram we have before us. I will take us through the procedure. You are provided with a variable DC power supply. This is the variable DC power supply. We are going to vary the DC. DC means direct current, and a battery can produce direct current. So a key, this is a key. This is a key for this experiment, and then we have a voltmeter. This is the voltmeter, and then we have ammeter, and this is the ammeter. We have the resistor, and then the batteries, and then the connection wires. So let's quickly look at the instruction for the experiment. They ask us to, number 1, set up the circuit as shown in the diagram above. That is the circuit. This is the E here. There's a wire from here to the key. This is the wire. This is the wire that runs to the key. This wire runs from here to the key. From the key to the ammeter, this is the wire that runs to the ammeter. This is the wire here that runs to the ammeter. You put it this way, this is what you have. So this is the wire to the ammeter, and then from the ammeter to the resistor. The ammeter to the resistor. This is the resistor, a fixed resistor, 2 ohm. And then from the resistor back, from the resistor, this is the cable from the resistor. Can you see that? The cable from the resistor back to the variable power supply. And so before we begin, I want to give us an orientation on how to read the voltmeter. The voltmeter is having values from 0 to 3, and we also have smaller units of calibration here. We want to know the value for each small line here, so that anytime our reading falls in between any of this line, we are going to know the exact reading, the exact value at that point. So we have 0 to 1. If you count it, you have 10 small lines here. So it means that the value for each small line here is 1 divided by 10. If you do that, we are going to have 0.1. So 1 divided by 10 will give you 0.1. So for the voltmeter, the value for each small box is given to be 1 divided by 10, and that will give you 0.1 volts. is the value for each small box. How about the ammeter? The ammeter have two calibrations here. We have the up calibration and then the down calibration. If you are going to make use of from 0 to 1, you have to read the up calibration, which is 0 to 1. But if you are connecting from 0 to 3, you have to make use of the down calibration, which is from 0 to 3. So the up calibration is 0.2 divided by 10. We give you the line, the value for each small line. And then for the down calibration, it is 0.6 divided by 10. It will give you the value for each small line. So if you do that, 0.6 by 10, you are going to have 0.06. So for the ammeter reading, the value for each small line is 0.6 divided by 10. We're going to have 0.06. Yes, we're going to have 0.06. So having gone through the orientation of how to make use of this measuring device, it is time for us to run the experiments. But before we do that, we are going to generate what we call the table of values. The table of values for each experiment is something you must not joke with. In every experiment, the table of values carries the bulk of the mark. For this particular experiment, the table of values is going to carry 10 solid marks. So I'm going to guide you how to generate your table of values even if you don't know how to do it. So let's begin. They ask you to set up a circuit as shown above, and above with E equals to that. Meaning your table of value is going to have a parameter called E. So what we are going to do is we are going to draw something like, write something like you have. Okay, let's write observations or table of values. So write serial number, that is the number of time the experiment is going to be run. So if you count, we have set this equal to that, and then repeat the experiment for values of 1, 2, 3, 4. Meaning we are going to run the experiment for 5 times. The first time is here, and then the second time is there, third, fourth, fifth, and then so we have to draw a straight line here. So we have 1, 2, 3, 4, 5. We are done with that. So we have E as the first parameter in this experiment. So we're going to record E, and the EMF is measured in the units of volts. So we write volts. Can you see that? Yes. So we draw another straight line down here. Another straight line down here. So we are done with that particular one. So they say close the key, take and record the voltmeter reading V. So we are going to have the voltmeter reading here, and V is also measured in the unit of what? Volts. So we draw a straight line here again. So the next one is take and record the corresponding ammeter reading I. We are going to take the reading from here, and the current I is measured in the units of ampere. So I/A, you draw a straight line down here. They ask us evaluate V inverse and I inverse, meaning your table of value is going to have V raised to -1 / volts raised to -1. That is the units. You draw a straight line here, and also your I raised to -1 / ampere raised to -1. So this is your table of values. So this is how your table of values must look like. We call this the composite table. If you don't do it properly and also include the SI unit, the examiners will mark you down. They'll mark you down. So right now we are going to run the experiments proper. Instruction number 1, set up a circuit as shown above. that has been done. The circuit is already set. It is time for us to perform the experiment. So they asked us to introduce 1 volt. So one of this is 1.5. You can see 1.5 there. 1.5. So the last value is 7.5. So let's record the first value. The first value is 1.5. So we'll write 1.50. We're going to record everything to 2 decimal places. The next value is 3.00. So we'll write 3.00. The next value is 4.50. So we'll write 4.50. The next value is 6.00. So we'll write 6.00. The next value is 7.50. So we'll write 7.50. I believe you are not confused how we get these values. One of these is this. 2 of this is 3. And 3 of this is 4. And then 4 of this is 6. And then 5 of this. 5 of this will give you 7.50. I hope that is well understood. So right now we are good to go. So this is your table of values once again. So let's begin the experiment. So we are going to plug in this key here. Can you see that? And then take this guy and connect it here. Yes, that's it. And then the next thing is we are going to make the circuits. We plug in the key. You can see that it is reading already. So let's quickly read what is on the voltmeter. The voltmeter reading here is, we have from here to here is 5, 6, 7. It's reading 7 volts. So let's quickly note it down. We have 7 volts. So 7 times 0.1. So for the ammeter reading, we have, let's count together. This is 1, 2, 3, 4. 4. Okay, 1, 2, 3, 4, 5. That is 5. The ammeter reading is 5 ampere. So the actual reading is 5 times 0.06. So let's quickly tabulate the reading. Yes, let's tabulate the reading. So we have 7 times 0.1. That will give you 0.7. So we'll have 0.7. Don't write 0.7 but 0.70. The next value is 5 times 0.06. If you do that, you will have 0.3. So we'll write 0.3. Sorry, that is the ammeter. Sorry, 5 times 0.3. So we write 0.30. That is the ammeter reading. 7 times 0.1 for the voltmeter. 5 times 0.06 for the ammeter. Sorry, this is a mistake. I'll correct it later. So the next line of action is to add 1.5 to 1.5. That will give you 3. So we are going to put it here again. That is it. And then shift this to this place. This is what you have now. So if we do that and we plug in the key, we are going to have another value again. So we plug in the key. Yes. So the new reading for the voltmeter is, this is 10, 11, 11.5. 11.5 for the voltmeter. So we have 11.5 times 0.1. For the ammeter, we have what? We have, that is 10, 9. We have 9. We have 9 ampere. So 9 times, for the ammeter, we have 9 times 0.06. So if we do that quickly, this is what we are going to have. So we have 11.5 times 0.1. That will give you 1.15. So we have, for the voltmeter, we have 1. We have 1.15. 1.15. And then for the ammeter, we have 9 times 0.06. We have 0.54. So here we have 0.54. I hope you are following. We have 0.54. We are going to run it for the third time. This time, 3 volts plus 1.5. We are going to have 4.5. So we increase the value for the EMF. Yes. And then we shift this to this place. Yes. You can see that. That is it. And then we are going to make the circuits. So we make the circuit by plugging in the key so that it is reading clockwise. So the voltmeter reading for this experiment right now, if you bring it very close, what do you see? We have, this is 10, this is 15, this is 16.5. We have 16.5. So for the second value, we have 16.5 times 0.1. For the ammeter reading, we have, this is 10, 11, 12, 12.5. 12.5. So we have, let's quickly unplug it so that we don't drain the battery. We have 12.5 times 0.06. If you do that, what are you going to have? If you do that correctly, what are you going to have? So we have 16.5 times 0.1. If you do that, you're going to have 1.65. For the ammeter reading, you have 12.5 times 0.06. If you do that, you're going to have 0.75. So we have 0.75. We run the experiment for the fourth time now. For the fourth time. Meaning we are going to increase the value of the EMF of the circuits. So we are increasing it to 6 volts now. So from here to here is 6 volts. So this is 6 volts. 4 will give you 6 volts. Can you see that very well? So we are going to shift this to this. Can you see that? We shift that to that. And then we make the circuits. This is the key. And then we make the circuits. Quickly, what we have here? We have, you can see this is 10, 20, 21. For the voltmeter reading, we have 21. So we have 21 times 0.1. For the ammeter reading, what do we have? For the ammeter reading, we have, this is 10, 11, 12, 13, 14. Okay, this is 10, 11, 12, 13, 14, 15, 16. We have 16. Can you see that? Yes, we have 16. So we have 16 times 0.06. Let's quickly break the circuits so that we don't drain our battery. That is actually part of the precautions in the experiment. So let's quickly compute. So we have 21 times 0.1. If you do that, you are going to have 2.1. So we have 21 times 0.1 have 2.10. For the ammeter reading, you have 16 times 0.06. If you do that, you have 0.96. So we have 0.96 96. This is the last part of the experiment. One battery is remaining here. So we plug in the fifth battery, and we are going to, the fifth cell, and we are going to have 7.5. This is it. So this is the arrangement. This is it, is 7.5. So we connect this to the end of this. Yes, yeah, this is what I'm saying. And then we now plug in the key to take the reading. So last lap for the experiment, baga. What do we have as the voltmeter reading? Quickly, it is pointing at exactly 10, 20, 25. Can you see that? 25. So we have, quickly, we have 25 times 0.1. For the ammeter reading, it is pointing exactly at 19. Can you see that? Yes, 19. 19, yes. So we have, we break the circuit. So we have 19 times 0.06. So if we do it, what are we going to have? Quickly, let's do it. We have 25 times 0.1. If you do that, you have 2.50. So we have 2.50. Then for the ammeter reading, we have 19 times 0.06. If you do that, you have 1.14. So you have 1.14. Behold your table of values. So this is your table of values or observation. But that is not all. We are going to find the inverse of V and the inverse of I. The inverse of V is simply 1 divided by every value here, we put the result here. 1 divided by every value here, we put the result here. And anytime you are recording inverses, and the inverses or the square roots or the cube roots or the squares or the logarithm of parameters in an experiment, you have to record it to 3 decimal places. This is what we call the composite table. I repeat again. So we are going to record everything here to 3 decimal places. Please take notes. So let's start. We start with the first one, which is 0.70. So 1 divided by 0.7. We are going to have 1.429. So we have 1 divided by 1.5. If you do that, sorry, that is not it. 1 divided by 1.15. If you do that, we are going to have 0.870. 0.870, that is 69. Approximately, we're going to have 70. That is what you are going to have. So, can you see that? So, again, 1 divided by 1.65. If you do that, you are going to have 0.606. We have 1 divided by 2.1. If you do that, you are going to have 0.476. 1 divided by 2.5. If you do that, you're going to have 0.400. It is 0.4, but you have to record it 0.400. Yeah, you don't need to come and write 0.4 here. You need to have consistent what we call consistent values. If the values are inconsistent, the examiners will mark you down or they will deduct a mark from you. So we are going to find the inverse for I now. So we have 1 divided by 0.3. If you do that, we have 3. We have 3.333. So the next one is 1 divided by 0.54. If you do that, you have 1.852. So the next one is 1 divided by 0.75. 1 divided by 0.75. If you do that, you have 1.333. 1 divided by 0.75. That's the result. The next one is 1 divided by 0.96. If you do that, you are going to have 1.042. 042. The last one is 1 divided by 1.14. 1 divided by 1.14. If you do that, you're going to have 0.877. 0.877. So this is a table of values. So the whole of this carries 10 marks. If you do it correctly this way, you have your 10 marks. So to this, we have come to the end of this particular video. In the next video, I will be using these values to plot our graph, and I'll teach you how to plot graph correctly and get all your full marks. And we are going to do all the deductions. As you can see, these are the other questions. We are done with this particular section here. The next thing is plot your graph, determine the slope, the intercept, state 2 precautions, state 2 method by which an electric current can be produced, calculate. This is the calculation we are going to do. So we are going to do all this in the next video. That is your marking scheme. You can quickly screenshot this. That is how your marking scheme will look like. So see you next time in the next video, where I will plot the graph and do all the following calculations. Kindly subscribe to my channel and share this video. Make your comments so that I will prove. God bless you. Bye-bye.